The first one is half wave with AC voltage, and then transformer, use ideal transformer. And of course we need diode. Okay, and as load, I use resistor. And then as we know, at AC voltage we produce triple voltage, so we use capacitor as smoothing filter. Then we connect all the components. Okay, then we put ground here. So ground here. And then of course voltage pin, one here for the input. Here, this one for the VF2 for the output transformer, this one for output load. Then this one we change to 400 series because that one is ideal one. I would like to use 10 mil. Okay, and of course this one, because we're using AC voltage, we need sinusoidal. One amplitude 50 frequency. Run the transfer analysis. One cycle is 20 amp, so I need 5 complete cycles, so 100 amp. So we get like this. Now I will change the capacitor to a bigger one, 2200 mil. Okay, we see, we run the analysis. Become like this. Okay, and I would like to change this one to 5 amplitude, 60 frequency. So the resistor 10K, $33 mil. And run the analysis. Got like this. Okay, now for full wave, we start with center tap and AC voltage, and then I will adjust transformer with center tap. Okay, and then of course we need diode. Then we need 2 diode. Okay, of course we need load. Load means the resistor. And also capacitor as a smoothing filter for the ripple voltage. And now we should connect everything together. And as for this one, we connect it to the center part. Okay, this one also connect the component. So we need ground here and also a ground here. Voltage pin here for the output, for the input. This one for the transformer output. and another one here for the load output. And same one, we need to change this one to the 4002 series. Okay, so this one to the 4002 series. We need to use sinusoidal, one pistic, same one. So I would like to use 2.2 amp. Okay, the ratio is 2. Okay, we see how it goes. 5 complete cycle is 100 amp. Okay, we get like this. Now, it's because the input is 1. When the input is 1, the output upper part also equal to V input, lower part also equal to V input. That's why equal 1 also. And after it passed through one diode, it experience voltage drop of 0.7. That's why it's at 0.3. Now I would like to change the ratio to 1. We'll see what happened. Okay, the load output is at 0. Okay, we will look first at the transformer output. It's because the upper part is equal to, it's because ratio is 1. So V input over 2. For lower part also, V input over 2. So that's why it's at 0.5. And then after it's going past through the diode, experience 0.7 voltage drop, which is it can't encounter. So it approaches 0. Okay. The last one is full wave bridge. So we need AC voltage and then an ideal transformer. Okay, this time we need 4 diode to construct the bridge concept. Change all the setting to okay, I've changed all the 4 diode value to the ideal value. And of course we need a load. And also a capacitor as a smoothing filter. Okay. And we need to connect everything. Alright, so I would like to use 2.2 amp. Okay. Connect this one. This one. Put ground here. Put ground here. So put ground here. Okay. Change this one. This one also there. 150. Okay. Ratio to, we'll see what happened. We run the transition analysis. 5 complete cycle is 100 amp. Okay. So I forgot to put the voltage pin. One here for the input and one here for the output. So I corrected. I do have some mistake just now. So I go through transition analysis. I get like this. First, I'm using ratio 4. If you are using ratio 4, basically the input is 1, it becomes 4. And then because 2 diode, voltage drop is 1.4. So 4 minus 1.4 is 2.6. That's why it become like that. We change to ratio 2. You can see. Okay, the transition analysis. Okay, input 1, the output will become 2. 2 minus 1.4 is 0.6. Okay, I think that's all. Thank you.